Hello everybody, I'm here in my home science laboratory, aka my kitchen. I can't move the camera when I'm in the middle of doing this. Take two. I've cleared off all of the area right around here so that I can do this science lab, meaning everything else is behind me. Okay, so what we are doing is we are going to be doing Activity 61 from the SEPUP book, Mixing Hot and Cold Water. Our inquiry question is, what happens to the energy when hot and cold water are mixed? And I'm going to be running 3 different setups today. The first one is going to be equal amounts of hot and cold water. The hot water is going to be just around 60 degrees Celsius. The cold water will be 20 degrees Celsius. The second experiment that I will do will be twice as much hot water as cold water. And again, those temperatures, if everything goes right, should be around 60 degrees and around 20 degrees. The final activity will be with half as much hot water as there will be with cold water. And you will be taking the data that I am collecting in this data table, which is provided for you in the assignment. After we are done with this, you're going to complete the analysis questions, which I have also typed up for you. So I went back to the school this last week, and I grabbed a couple of things. We have a scale which can measure grams. We have a couple of thermometers, and I didn't think about grabbing a graduated cylinder, which I was kind of bummed about, until I remembered the beauty of the metric system, which is that 1 milliliter of water, which is what I'm supposed to be measuring this in, is equal to 1 gram. I can see that I have just about 100 grams, which is equal to, well, it'd be 97 milliliters, but I'm going to count that as 100. And the beauty of my mark also is that I have 50 milliliters right there, so that's going to count as both my, I'm going to do 100 milliliters instead of 60. Okay, so I've got 100 milliliters of cold water. That cold water is at 20 degrees Celsius. So I could mark in here the cold water starting temperature is at 20 degrees Celsius. So I've got 100 grams and the water is at, and mind you, this number is going up right now because I have this thermometer in there. So let's watch as this climbs until it becomes stable. All right, go ahead and mark in your data sheet 58 degrees Celsius. That's going to go right here for the starting temperature of the hot water. And I'm going to go ahead and add equal amounts of cold water to the hot water. And we're watching as the temperature decreases. It looks like it's becoming pretty stable at around 42 degrees Celsius. So we can put in our final temperature for both liquids. Let's wait until that becomes in focus. Oh, it's probably got condensation on the top. Okay. Final temperature is going to be 42 for each of these. Just to verify, yep, it is held stable there. All right, I got 50 grams or 50 milliliters of cold water, 50 exactly because I'm amazing, and that is currently at looks like 23 degrees. 23 degrees is what you could mark for experiment 2, the cold water. And we have 99 grams of hot water. That hot water is at, that's cruising. Cruising for a bruising. Here we go. Might need to move that plastic thing. I'm assuming it has lost some thermal energy. And I'm back. That number, 100 grams or 99 grams is still valid. And now my temperature is 63 degrees Celsius. 63 degrees Celsius for the hot water in experiment 2 starting temperature. All right, so I'm going to go ahead and add the 50 milliliters of cold water to this. We'll just give that a little wangle jangle, and if I'm satisfied with 49 degrees Celsius, we could record that as our final temperature for number 2, 49 degrees Celsius for the hot and for the cold. For our final experiment, we're going to be doing 50 milliliters of hot water. Oh yeah, 50 milliliters of hot water. That hot water is at some temperature, which I will get in just a second when this thing goes up. We're going to have 100 milliliters of cold. Jumped the gun a little on that one. Pretty good. Got a couple drops on there, so it's going to add a little bit there. That'll do. Okay. Excellent. All right, our hot water is, oh, boom shakalaka, right at 60 degrees. Don't know what's happening with the camera there. It's having trouble focusing. There we go. 60 degrees for the hot, and for the cold, we are at 22. Fantastic. I'm going to go ahead and add that cold to the hot. Give it a little wangle jangle, and watch temperature drop. Oh, look at it cruising. Wow. Very cool. Look at these fingernails, too. These are quarantine fingernails right here. And our temperature looks like it's slowing down. Probably going to stop at around 35 degrees. Okay. I don't know what I recorded for my starting temperature. You can look back in the video for that. 35 degrees for the final temperature. All right, so now you've got your data all across here. To find the temperature change, you're going to subtract the starting temperature from the final temperature. So our final temperature, I don't remember what this one was. Let's say it's 45 degrees here. Starting temperature was 60, so that would be 15 degrees. So negative 15 degrees, 45 minus 60 is going to give us a negative temperature change, right? It's going down. All of these ones for the cold should be positive.